In this question, compound P is reacted with hydrogen gas in the presence of nickel catalyst to form compound Q. Now, if you look at the structure of compound P, it is an alkene with 3 double bonds. Here, this one, and the third one. Right, so this alkene double bonds will be reduced to alkane. So we are going to add hydrogen to each of the carbon in the double bond. Then all these double bonds will be gone because they became a saturated compound Q. 1, 2, 3, 4. This is the hydrogen. So erase this, erase this. So after removing the double bond, so it will become compound Q. So to save time, I've just copied the structure of compound P and erased the double bond to show you the structure of compound Q. So after saturation, this is what we get, and we are supposed to find the number of chiral carbon in the product Q, which is this compound. So we don't look at compound P anymore. Okay, we are looking for chiral carbon atoms in product Q. So let's look at the structure on the right hand side. There are so many carbons. I'm going to rule out those carbon atoms which are not chiral. So this carbon is bonded to 3 hydrogen. Okay, so it is not a chiral carbon. So those carbon which are not chiral carbons, I'm going to label them with the red dots. So this carbon is bonded to 2 more hydrogen. So it is not a chiral center. This carbon is also bonded to 2 hydrogen here, right? Not a chiral center. Now to remind you, chiral center, chiral carbon atom should attach to 4 different groups of atoms. So if they are already bonded to 2 hydrogen atoms, there's no way that they're going to be bonded to 4 different groups. So these are not chiral carbon. Right, this is a CH3, this carbon is not chiral carbon, this 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 is not chiral carbon, 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 not chiral carbon. Okay, now let's look at those that are in the center of the branches, okay, and they are more likely to be a chiral carbon. So let's look at first carbon, carbon number 1. Okay, it is bonded to a CH3. It is bonded to another H. Okay, and the other 2 neighbors, they are in a ring. So what can we do to confirm whether this is a chiral center or not? We will draw a plan of symmetry, okay, or we try to find whether there is a plan of symmetry around this carbon or not. So draw a line, go through this carbon and half the ring. And then we check left hand side and right hand side after drawing this plan. We have to see, okay, if they are not the same, they're not mirror image for both sides, okay, they're not mirror image of each other, then this compound is a chiral center. So I make blue dot for a chiral carbon. And now let's erase this dotted line because we have to check other carbon atoms. Okay, so now let's go to the next carbon, carbon number 2 here, right? So carbon number 2, it is bonded to this neighbor, another neighbor, another neighbor, and they are all a member of the ring. So again, to check whether it is a chiral carbon center or not, okay, I have to draw a dotted line, go through this carbon, half the ring, okay, and check whether left hand side and right hand side are the same or not. Okay, obviously this is not. So this is another chiral center. Now let's erase this dotted line again because I need to check more carbon atoms. Okay, let's go back to the pen. Now let's look at this. Okay, now this carbon is not a chiral carbon because it is bonded to two CH3 group, two identical CH3 group. So this cannot be a chiral center. I'm going to label this as red color because it is not a chiral center. Now this carbon, I'm going to number this carbon number 2. So let's look at carbon number 2. It is bonded to a neighbor, another neighbor, and another neighbor, and of course another H. I forgot this one is also bonded to another H. So 1, 2, 3, 4. Okay, and this another, except for H, another 3, they are in a non-asymmetrical ring. So let's look at number 2 again. Carbon number 2 again is bonded to hydrogen. Okay, another 3 in the ring. So if you draw a dotted line to go through this carbon and half the ring, okay, the ring is not symmetrical. So carbon number 2 is another chiral carbon. So I'm going to color it as blue so that now we have 1, 2, 3, 3 chiral carbon atoms. Now there are more here. This one, this carbon number 3 bonded to a CH3, bonded to a H, and the other 2 in the cyclic compound or one of the members in the ring. So we will draw a line to go through this carbon, okay, and probably to have this. Let me see how do we have this compound. Okay, let me draw the structure. Probably I can just have this compound by doing this. Okay, go through this carbon to this one. Okay, because between these two rings, okay, this is probably the center. So apparently left hand side and right hand side, they are not the same. So this is another chiral center. Right, let's check a few more. Okay, and you know that I'm going to erase this again. Okay, it's kind of tedious, but this question is not difficult, right? So now another one, carbon here, okay, bonded to CH3, bonded to 2 more carbon and another H. So it's very similar to this chiral carbon number 3. Okay, if you draw the line to half the ring, it won't be symmetrical. It doesn't matter you draw a line to go through any of the carbon, the compound is not symmetrical, right? So this is another chiral carbon. So we have 1, 2, 3, 4, 5. Let me see. There's another carbon that we haven't checked, which is this one. Now this carbon is also bonded to 2 more hydrogen. Right, so it is not a chiral carbon. Let's label it as red. Now let's go through everything again and see if we have checked every single carbon. Okay, check, 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 check. Okay, don't forget to also check the branches. Right, all carbon checked, and we have labeled the chiral carbon with a blue dot. So now let's count the number of chiral carbon atoms. 1, 2, 3, 4, 5. So the answer is 5.